welcome. You should be on page 36 of your pre-algebra quarter 2 notebook. In this video, we're going to talk about graphing linear equations using a table of values. So I just want to start by saying, let's look at this graphing linear equations. And if you notice in the word linear, you're going to see the word line. And so what we are graphing are actually lines. There are equations that represent lines. And where are we going to graph these lines? Well, we're going to graph them on the coordinate plane. So the coordinate plane allows us to represent algebra in a picture form, really. So the graph of an equation in two variables, when I'm talking two variables, I'm talking x and y, is the set of points. So you're talking about ordered pairs, which of course is x, y, in the coordinate plane that represents all the solutions of an equation. Ordered pairs are actually the solutions to the equations. So what are we going to do when we graph? The first thing we need to do is we want to make sure that the equation is written in function format. And what I mean by that is the y must be isolated. There's a fancy math term, but basically y must be alone. The next step we want to take when we're graphing the equation is use a table of values. Oops, I was getting all into writing table of values. Use a table of values to find points. Then we're going to plot the points and connect the points to form a line. So this is a lot of words now. Let's see what it looks like when we're actually doing this. In the first four problems here on page 36, we're going to focus on rewriting the equations. We're going to focus on this step one. Now, step one is kind of what I call a maybe step, because maybe you'll have to do this, maybe you won't. If y is not alone, you have to do step one. So let's look at this equation. Y plus 3y equals -5. Is y by itself? No, y is over here on this side with the 3x. So what I want you to think about is two things. We could kind of use our understanding of stay and go to solve this, or we can use our understanding of inverse operations. So I'm going to explain with stay and go first. If I'm thinking about stay and go, what I want to stay is the y. The y must stay on the left. Everything else must go. So let's take a look at this one. I've got the y. I did say it needed to stay on the left. So y stays on the left. Well, this is everything else. It's going to go, and just like with the stay and go, it's going to go as the opposite sign. It will go as -3x. And because this is everything else, it is going to stay as a -5. And I should have written go everything else. So we want, excuse me, our y to stay here on the left and everything else to be on the right. So here we go. Let's take a look at our new equation, which is y equals -3x minus 5. Now let's say you don't want to stay and go. You just want to think about the idea of inverse operations. I can always move something from to the opposite side by using the opposite operation. Opposite side, opposite operation. So in this case, again, I want to get this y by itself. If I want to use this plus 3x to get it to the opposite side, I'm going to use the opposite operation. The opposite operation of plus 3x is minus 3x. And I get y equals negative 3x. I can't combine that with a negative 5 because this is a constant and this is a coefficient and a variable. And I come up with the same equation. So 2 different ways, same equation when I rewrite it. So let's take a look at number 2. And if I stay and go, I know I want my y to stay here as a y. Everything else has to go to the right. So this will go as a positive 1/4 x, and this will stay as a positive 7. So I get y equals 1/4 x plus 7. If I wanted to use the opposite operation, if I want to move minus 1/4 x to the opposite side, I'm going to add 1/4 x. And I'll show you that just so you can see it very clearly. Over here, I'm going to put y minus 1/4 x equals 7. I will add 1/4 x to both sides. And I will get y equals 1/4 x plus 7. Same equation, just 2 different kind of thought processes behind that. All righty. So let's take a look at this one. I want the y to stay over here. So it will stay. This needs to go to the right. So it's going to go over as a positive 5x, and this will stay on the right as a positive 2. So my equation is y equals 5x plus 2. If I think about it, let me just separate those two. I like everything to look the same. If I think about this, minus 5x plus y equals 2. If I want to move minus 5x to the opposite side, I will use the opposite operation, which is plus 5x. And I'll still get y equals 5x plus 2. Okay, last one, stay and go might help you in a sense of how to figure this one out. But before I even think about this, I want to think about what I know about equality. I'm just going to write this down over here. If I have 5 equals 2 plus 3, isn't that the same as 2 plus 3 equals 5? Can't I switch the 2 plus 3 to this side and the 5 to that side? And it still is equal, right? Well, I can do that with this equation too. I can move this piece. I can just switch them. And I think by doing that, it makes it a lot more clear what I need to do, right? Because I want this y over here to stay on this side. I want it on the left. Now this is a plus 8x. It will go as a negative 8x over here. And this stays as a plus 11. So I get y equals negative 8x plus 11. If I'm going to use my opposite side, opposite operation approach, I'm going to think about it the same way. I will rewrite it so my y just starts over here. And now, opposite side, this is a positive 8x, so I'm going to opposite operation, and I get y equals negative 8x plus 11. So that's going to be all for this video. Hopefully it was helpful, and thanks so much. Bye.